Hello students, welcome to our today's video. Today we will discuss about types of relation. You must have remembered that in our last video we started with the basics of relations and functions, and for that we learned about the sets, what are sets and what we can do with sets. So let's start with our today's topic. Today we are going to discuss about the types of relation. Let me recall you what is a relation. Relation is a combination connection which is between two elements. There must be some connection, defined connection between two elements, and then we call it a relation. So let's start. First of all, we have empty relation. A relation R is a set A is called empty relation if no element of A is related to any element of A, that is R equals to phi. Let's suppose take an example to understand this definition. Let's suppose I have a set, मेरे पास एक set है A 1, 2, 3. What will be its Cartesian product? Cartesian product will be equal to A cross A. First of all, first element will multiply with first element, that is 1, 1, then 1, 2, then 1, 3. Similarly, 2, 1, 2, 2, and 2, 3, and 3, 1, 3, 2, 3, 3. These are the all possible pairs for this set. This is Cartesian product. Now I am defining a relation R. What is the relation? Relation R says first number is 5 less than second number. Means मैं उन दो elements को लूंगा अगर जो first element है that is 5 less than the second element. Now I can write this definition of relation in another form. A R B. A is related to B if B minus A equals to 5. First element is 5 less than second element. What it means? If I subtract first element from second element, I get 5. That is why I have written B minus A equals to 5. You must be seeing here. I can also write this relation in another form, that is R equals to A comma B such that B minus A equals to 5 and A comma B belongs to A. Now can you give me any pair out of this Cartesian product for which the relation between two elements is 5? Let's check. 1, 1, relation is not 5, difference is not 5. 1, 2, difference is not 5. 1, 3, 3 minus 1 not equal to 5. 2, 1, 2 minus 1 not equal to 5. 2 minus 2 not equal to 5. 3 minus 2 not equal to 5, 1 minus 3 not equal to 5, 2 minus 3 not equal to 5, and 3 minus 3 not equal to 5. You can see out of this Cartesian product there is no single element which can satisfy this relation. That's why I write this relation with the empty boxes, yani ki empty relation. That's why this type of relation are called empty relation. Let's go further. Now we will talk about universal relation. आपको याद होगा from the definition of set, what is universal set? Universal set is a set which contain all the set in particular context. Similarly, universal relation, what it seems to you? A relation R in a set A is called universal relation if each element of A is related to every element of A, that is R equals to A cross A. Now let's take an example to clear the concept. I am saying I have a set A 1, 2, 3. What will be its Cartesian product? Cartesian product will be A cross A. Let's write all the possibilities again. 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and 2, 3. 3 comma 1, 3 comma 2, and 3 comma 3. These are the all possible values which we carry in our Cartesian product of the set. I defined another relation R, and what it is, it says difference between first number and second number is 5. It is different from the other one. Here I am saying, see this type of definition, A R B. I will write it B minus A is less than 5. I am correcting myself. The relation is the difference of two numbers is less than 5. So B minus A, mode says A minus B and B minus A both are equal. The difference is less than 5. I can write it in another way, R equals to A comma B, such that B minus A is less than 5 and B A comma B are belongs to capital A, the set. Now let's check, are there any pair of elements in Cartesian product which satisfy this relation? 1 minus 1, it is 0. Difference between set is 0, which is less than 5. So difference between 1 and 1 is less than 5. So I put this pair in my relation. Now I will check 1 comma 2. This is also difference is 1, which is less than 5. Then 1 comma 3, difference is 2, so it is also less than 5. Then 2 comma 1, difference is 1 and again less than 5. Then 2 comma 2, the difference is again less than 5, and 2 comma 3, difference is 1, which is less than 5. Similarly, if you see for all other 3 comma 1, 3 comma 2 and 3 comma 3, the difference is 1, 0 or 2 maximum. All these differences are less than 5. So all pairs of my Cartesian product are satisfying the relation which is saying कि the difference है वो मेरा 5 से कम होना चाहिए. The difference must be less than 5. It can be any number less than 5. And all pairs of Cartesian product are satisfying that. So that's why I included all the pairs of Cartesian product in my relation. That's why this is universal relation. Now let's go further. What are reflexive relation? Now there is a universal relation and empty relation are some sort of very similar to each other, and the second type of all other relations are, which we will discuss, are there is another pair. So before starting these type of relations, the second part of type of relation, I want to conclude these two pairs again, empty relation and universal relation. A short recap. What is empty relation? Empty relation says if no pair of Cartesian product come in my relation set, then such relation is called empty relation. You have seen the example. Okay, second is universal relation. If all the elements of Cartesian product come in my set of relation, then such relation is called universal relation. In today's video I will give you some homework and you have to respond the answer of those questions in the comment after the video will be uploaded in the our channel. So you are supposed to give the question, you are supposed to give the examples of empty relation and universal relation. Try and post it here. Then we will start further. We are saying what is reflexive relation. Now there are two things, be careful. It is about naming. जब हम किसी का नाम रखते हैं, there can be two possible reasons. You must have seen, you have friends, if he is very tall, आप उसको लंबू कहते हैं because of his characteristics. If he is a little healthy, you can call him Motu. That's not, I think, morally correct, but in friends, we give names because of their characteristics. If some of my friend is very intelligent, I कहूँगा होशियार. I name him Hushyar. So when you name some person, there can be two reasons. First, because of his characteristics, his properties, and second, because of his father, the surname came from the father. Similarly, in mathematics or in any field, a name of any object, a thing, concept can be based on two things. First, because of his characteristics, and second, because who invented that concept. Be careful about it. First of all, now let's see this concept in about reflexive relation. Reflexive, the word came from his characteristics. We will see how. And the surname relation came from his father, because we are studying types of relation. So reflexive relation is a type of relation. So he get this surname relation in heredity, and how reflexive is a characteristic of this relation. We will see this. Now just think about this. What is reflexive? Reflexive came from a word reflection, and when you see reflection, you many times you see your reflection in water and mirror and in many things. And the special thing about reflection is, reflection की खास बात क्या है, जिस चीज का आप रिफ्लेक्शन करते हैं, this है, you will get exactly the same thing on reflection. It means when you're talking about reflection relation, two things are between reflection relation if they are exactly same. So I will say an element A is related to another element A if they are exactly same. Now see the mathematical definition. It says, must be on your screen, a relation R is a set A. A relation R in a set A is called reflexive. When we will call it reflexive, if A comma A, both elements of pair are same. If A comma A belongs to R, if A comma A, जो A comma A टाइप के मेरे पास एलिमेंट्स होंगे वो मेरे रिलेशन के अंदर होने चाहिए, तब मैं उस रिलेशन को कहूंगा कि दिस इज रिफ्लेक्सिव रिलेशन. लेट्स टेक एन एग्जांपल. We will start with previous set A 1, 2, 3. You have seen the Cartesian product A cross A. We are familiar with this. Now I am defining a relation. First number is equal to second number. Second way of writing a relation, A is related to B if it implies A equal to B. मैं उन पेयर्स को अपने रिलेशन में लूंगा अगर वो दोनों इक्वल हैं. और थर्ड वे ऑफ राइटिंग रिलेशन, R equals to A comma B such that giving condition A equals to B and A comma B belongs to A. A equal to B होना चाहिए and A comma B belongs to A होना चाहिए. Now let's check from the Cartesian product which pair satisfy this condition. First of all, 1 comma 1. Is this satisfying the condition 1 equal to 1? Yes, it is satisfying the condition. So I will took this 1 comma 1 in my pair 1 comma 1. Second, 1 comma 2, 1 equal to 2. No, this is not correct. So we will not take this in our relation. Then 1 comma 3. Just check. 1 equal to 3. No, obviously not. So I will not take this in our relation. Then 2 comma 1. 2 equal to 1. No, you can't think of it. Leave it. Then 2 comma 2. 2 equals to 2. Yes, it is correct. So I will take this 2 comma 2 in my relation. Then 2 comma 3. 2 equal to 3. Not possible. Leave it. 3 comma 1. 3 equal to 3. 3 equal to 1. Not possible. Then 3 comma 2 check. 3 equal to 2. Not possible. Then 3 comma 3. 3 equals to 3. Yes, it is possible. This is satisfying the condition of our relation. So I will put this element in my relation. So now we check what we have in our relation. The relation contains 1 comma 1, 2 comma 2, 3 comma 3. You can see in this relation for all elements of a 1, 2 and 3. We have pairs like 1 comma 1, 2 comma 2 and 3 comma 3. That's why this reflexive relation, this is a reflexive relation because it is satisfying the condition. हर एलिमेंट A के लिए A comma A टाइप के पेयर्स मेरे रिलेशन के अंदर होने चाहिए and it is satisfying the condition. You can see, search, explore some other examples of reflexive relation. Let's go further. Symmetric relation. What is symmetry? Again, the term symmetric came from its characteristics and the term relation came from a heredity because of types of relation. What came to your mind when you think of symmetry? What is symmetry? Just think. It is like if I have a circle and I draw a line in mid of it, you can see the left side image and right side image are very similar. You can also see my hands. If I draw a line in between my thumbs, you will see that these and this are symmetry. There is symmetrical line between them. These can be overlapped. So this is we call symmetry. What is this? Where this happens? Now one more thing. If in this hand I name this finger A and name this finger B, what will be like? A comma B. पहले A आएगा and then B. Now I will see symmetric image of it. Here thumb is B, तो पहले B आया and then A. So when I am talking about symmetry, it will be A comma B and B comma A. This is something like symmetry. Now let's see this in our symmetric relations. What symmetric relation is? A relation R in a set A is called symmetric if A1 comma A2 belongs to R. First condition, two elements belongs to R. It implies that A2 comma A1 order is changed. A2 comma A1 belongs to R for all A1 A2 belongs to A. Means if A1 A2 belongs to R, then A2 A1 must also belongs to R. This is we call symmetric relation. Take a mathematical. Let's take a mathematical example. Example, for set A 1 comma 2 comma 3, taking the that example again, I have Cartesian product all the possible pairs done. I'm not repeating that. Defining a relation, difference between first number and second number is equal to 1. जो पहला और दूसरा एलिमेंट हो पेयर का, उनके बीच का जो डिफरेंस है वो 1 होना चाहिए. प्लस माइनस से नहीं, मुझे ऑर्डर से मतलब नहीं, डिफरेंस 1 होना चाहिए. I can define this in another way. A or B, if A minus B minus A mod equals to 1. What it means? I am saying the same thing, that the difference between them is 1. Okay, now let's check from the first. 1 minus 1 difference is not equal to 1, leave it. 1 comma 2 difference is 1, take it, grab it and put it in our relation. 1 comma 3 difference is 2, not equal to 1, leave it. Then difference 2 comma 1 difference is 1, take it in our relation. Here 2 comma 1, then 2, leave 2 comma 2. 2 minus 3 difference is 1, take it in our relation. Then 3 comma 1 difference is 2, not 1, so we leave it. Then 3 comma 2 difference is 1, so take this in our relation. Then 3 comma 3 difference is 0, not equal to 1, leave it. Now just think of this relation given here, 1 comma 2, 2 comma 1, 2 comma 3, 3 comma 2. You will see here, if I have 1 comma 2, then I also have 2 comma 1, 1 comma 2 and 2 comma 1. Symmetry here. Then if I have 2 comma 3, then I have 3 comma 2, 2 comma 3, 3 comma 2. I have symmetry here. So this type of relation I have symmetries. This. Then I call such relation symmetric relation. Okay. I am giving you a example, another example from real life. I am defining, I have a set A, and the set is set of all students in class 12, in your class 12. And I am defining a relation A or B such that A is friend of B. Now just think of it. If A is friend of B, it also means B is friend of A. Let me take an example from my class. I have students Shraddha and Shivani. Both of them are friends. I am saying if Shraddha is friend of Shivani, so Shraddha comma Shivani is a pair in my relation. I can also say Shivani is friend of Shraddha. So Shivani comma Shraddha, this is also pair in my relation. And for every relation like friendship, you can say this. There is another example, brother. If I am defining for all boys of family, then if A is brother of B, then B is brother of A, obviously. Okay, so here we are back. Thank you for waiting. There was some technical gap here. So what we was discussing, about this transitive relation. What are transitive relations? What do we understand by this relation transitivity? Let's carry on. Let's start from further. Um, yes, here we go. And we are taking this example, and I am taking the defining the relation by, I am defining this relation by less than. Here a comma b will be included in that if a is less than b, and you must base uh, how it will work. Hello. um, Hello students. So we are back. There was some technical error, and let's go further. What we will discussing? We will discussing about the uh, transitive relation. A relation R in a set A is called transitive if A1, A2 belongs to R and A2, A3 belongs to R, implies that A1, A3 also belongs to R for all A1, A2 belongs to R. Now let's go example and uh, what it says. The example again I am taking is 1, 2, 3 and A cross A equals to the Cartesian product, again same. I hope the technical error is removed and you must be the video must be clear to you. So I am continuing it with you. We have the set A equals to 1, 2, 3 and A cross A, the Cartesian product is again the same. Now I am taking the relation is first number in number A R B, and what it means, A is less than B. So how will we say it? R equals to A comma B, A and A comma B belongs to A. It means 2 points, 2 elements of pair will be related if first and then second. Okay. Now let's start from the Cartesian product. 1, 1 is not less than 1, leave it. Then 1, 2, 1, yes, correct. I will put this in my relation. 1, 3, 1 is less than 3, satisfying the condition, put this in our relation. Then 2, 1, 2 and 1, no. 2 is less than 2, no. 2 less than 3, yes, it is in our relation, put this in our relation. 2, 3. Then 3, no. 3 less than 2, no. 3 less than 3, no, not less than. So we will take, we are taking this 1, 2, 1, 3 and 2, 3 here in this set. Now you will see here I have 1, 2, 1, 2, and then I have to start. I need element with first element 2. जब मैंने बात की थी रुपेश, संजीव और अंकित की, तो पहले मैंने रुपेश और संजीव की बात की, उसके बाद मैंने संजीव और अंकित की बात की. तो मुझे बीच वाला जहां पर मैंने पहला पेयर एंड किया है, आई नीड टू स्टार्ट द सेकंड पेयर फ्रॉम दैट पॉइंट. सो 1 is 2 is here. Then you will see 2, 3 is also in the relation. So according to the law of transitivity, there must be 1, 3 in the relation. See, is it there? Yes, of course, this relation is also in the, this pair is also in the relation. So such type of relation, 1, 3, 2, 3, this is transitive relation. You must have the clarity. Now let's take a familiar example. I am taking A equals to set of is in class 12th, your class 12th in your school, and I am defining a relation R such that A is brother of B and A is, think of it, if A is brother of B, first person is brother of second. I am taking the name, these days Ramayana is going on TV, so Ram is brother of Lakshman and Lakshman is brother of Bharat. Can I say Ram is brother of Bharat? Yes, of course I can say. So the relation brother, it is a transitive relation. You must be clear now. First to second, second related to third, and then first related to third. Very simple, transitive relation. We will do some more questions, then more clarity will be there. So let's go further. Now, equivalence relation. Again, equivalence from characteristic and relation came from heredity. What equivalence means? Something like equal. It's like equal. How equal? Actually, the term relation we studied three type of in second part three type of relation. First is reflexive, then symmetric, and then transitive. The mathematical definition of reflexive relation says if there is a relation which is reflexive, symmetric, and it satisfies the vast majority of properties. This is a very special type of relation, and such type are named as equivalence relation. We will see why we call it equivalence relation in further lecture. There is a reason behind. For now, the definition of equivalence relation is a relation R in a set A is said to be an equivalence relation if R is reflexive, symmetric, and transitive. Okay, done. It is clear. Now then, you can example see I have A equals to 1 comma 2 comma 3, then Cartesian product is there. I have all the possible pairs. I am defining a relation R equals to difference between first number and second number is equal to 1. Here I am saying difference is less than equal to 1. I want to write less than equal to 1. You can see this in second type of relation. A or B, if B minus A is less than equal to 1 means जो दो मेरे पास elements है, mode क्या कह रहा है कि A minus B कर लीजिए या फिर B minus A के the same thing. So when I am saying mode A B minus A, the difference between them should be either less to 1 or it can be equal to 1. Now let's check again. You will see 1 comma 1 difference less than 1 in the relation. 1 comma 2 difference less than 1 in the relation. 1 comma 3 difference 2 not less than 1 not in the relation. Then 2 comma 1 difference is 1 in the relation. 2 comma 2 difference 0 less than 1 in the relation. 2 comma 3 difference 1 equal to 1 in the relation. 3 comma 1 difference is 2 not equal to 1. Then 3 comma 2 difference is 1 in the relation. 3 comma 3 difference 0 less than 1 in the relation. I have this relation tabular form 1 comma 1 1 comma 2 2 comma 1 and 2 comma 2. Now check the properties of reflexive, symmetric and transitive relation in it. First of all, we will check the relation for reflexive. Now here you will see in this I'm taking an example so that we can see when it is possible and when it is not. You will see there is 1 comma 2. So, and what reflexive relation? There must be the pair A comma A for all elements of A. So 1 comma 2 comma 3. There is for 1 there is 1 comma 1, for 2 there is 1 2 comma 2, but for 3 there is no 3 comma 3. Can we say it reflexive? Actually, this is the property of reflexive relation, that if you have the pair A comma A for some elements, then it is not reflexive. So in this case, this is not reflexive. But if I define a set A dash, let's name it A dash, and it contains element 1 comma 2. It contains element 1 comma 2. Then you will see that this relation R for set A dash, I am saying for set A dash 1 comma 2, this is reflexive relation because it contains 1 comma 1. For 2 it contains 2 comma 2. For both elements of A dash 1 comma 2 it is reflexive. Then talk about symmetric. 1 comma 1 it is symmetric of itself. Then 1 comma 2 there is 2 comma 1 in it. Then 2 comma 2 symmetric of itself. Done. It is also symmetric. For 1 we are talking about set A dash 1 comma 2. Then see the transitivity. If I have 1 1, both elements are 1 and 1 is related to 2, so these are there. You will see I will take 1 related to 2 and then I have an element 2 comma 2, so 2 comma 1, so 2 related to 1. What should be the product? 1 related to 1. So you will see it here, we have 1 comma 1. Now I will take them in reverse order. I am saying, see, I have element 2 comma 1 and 1 comma 2. So according to transitivity, there must be 2 comma 2, and we have the element 2 comma 2. So for a set A dash in which 1 comma 2 elements are there, only 2 elements 1 comma 2, this relation R, which I am this is not a equivalence relation of set A 1 comma 2 comma 3, but this is a equivalence relation for another set A dash, which is, we can say here. Okay, now let's go further. I'm giving an example of I should have written in this A dash a separate set, for which this is I have not written that, so I will correct that in later. I'm taking another example family which you must be familiar. Again, set A, set of all students in class 12, set of all students in your class, and relation I'm defining is A lives in house of B. Now just think of it. First we will check reflexive. A lives in house of A, कोई अपने घर में रहता है, so A related to A, reflexive done. Then symmetric definition says if A related to B, then B related to A. Let's say if A lives in house of B, can we say B lives in house of A? Yes, of course we can say. So A comma B in R, then B comma A is also in R. So this is a symmetric relation. Now let's check the transitivity. If A lives in house of B and B lives in house of C, they are staying there. So we can say A is also living in the house of C. Living in someone's house is, here I mean living with the person in his house. So in this you will say this example is reflexive, then symmetric, and then transitive. So in all it is a equivalence relation. Okay, now let's see what we have further. We have some questions for practice. Okay, what are the questions? First of all, I am defining a set and then a relation on that set. I have this. First question is A, set of all boys in your school. Just think, visualize there are all boys in your school, and I'm defining A comma B in relation if A is sister of B. Just think of it in reflexive. If can A is sister of A, can any girl can be sister of herself? Can be sister of himself? No. This is not a reflexive relation. Now see the I am saying the symmetric. A is sister of B. I am saying all boys in your school. So there can't be element A such that who is sister of B. Can you think of any pair? Jana, you were thinking about the set A, all boys of your school, taking two elements so that A is sister of B. It is not possible even, because there is no pair of boys such that one is sister. So this relation, in this relation, there will be no element, there will be no pair. So this relation is what? Such a relation in which there is no element, we call it, yes, you are correct. A relation in which there is no element, we call it empty relation. So this first relation is empty relation. Then second question, I am representing by T the set of all triangles in a plane. Just again visualize there is a plane and any triangle you can draw. Triangles in plane, that can be isosceles, equilateral, right angle triangle, of different measures, different shapes, different places, different things. All the triangles I am carrying, and I am defining the relation T1 comma T2 so that T1 is related to T2 with congruence. T1 is congruent to T2. Now just think of it. First of all, we will check for empty. Can you find a pair? क्या आपको एक ऐसा pair मिल सकता है दो triangles के जो आपस में congruent हो? Yes. अगर I am having all the triangles, then I can easily have the pair of two triangles which are congruent. This is not empty. Now in this pair, can all possible pairs will come in this relation? Not possible, I think. There are many triangles who are not congruent to each other. So they will be in Cartesian product, possibilities, but they will be not be in the relation. So this is not universal relation. Then reflexive, let's say, I put a triangle. I take a triangle and I am talking about the reflexive. So I need A for A element, A comma A must be in relation. So I take a triangle. Can we say that this triangle is congruent to itself? Yes, we know that every triangle is congruent to itself. So in this case, this is reflexive. For all triangles in your set, you can put this, yes, this is congruent to itself. Put this, yes, this is congruent to this. Put this, yes, this is congruent to itself. All triangles are congruent to itself. Sub triangle अपने आप से congruent है. So this is reflexive. Now talk about symmetric. If I have randomly one triangle from here and one triangle from here, what is symmetry? If A related to B, then B related to A. Now I'm saying it's related to this triangle. Is it necessary that this triangle is related to this? Yes, of course this is necessary. If two triangles are congruent, then they are congruent to each other. So this relation is also symmetric. Now let's talk about transitivity. Transitivity says first related to second, second related to third, then first should related to third. Okay, now let's see. I took randomly one triangle, then other triangle, and then third triangle. My first triangle is congruent to second. Done. Second triangle to congruent to third. Okay. Now first triangle is congruent to third. Think of it. Yes, obviously it is congruent to this and this is congruent to this. So these are all to each other. That's why this is transitive relation. And you must notice it is reflexive, it is symmetric, and it is transitive. So I can say this the relation of congruence on all triangles in plane is equivalence relation. Similarly, we can have further examples. You can note these, and I'll be happy if you tell me the answer for these. And after some time, this streaming will be uploaded on channel. You can check. You can answer for these last 4 options. And in next video, we will. I will announce the name of students who are correct, who gave the correct answer for these last 4. I am reading them. A set of all lines in plane and relation is L1 is parallel to L2. Then next set of all lines of plane and relation is L1 is perpendicular to L2. Then third is given, and then fourth is given. Just check them, give the answers for them in the comments, and we will announce the names of students with correct answer in next video. Next thing, this is done with types of relation. Now what will you do? In book of NCERT, you will see we have covered first part before the 1.1 exercise 1. In our next video, which is day after tomorrow, we will do the exercise 1.1 of NCERT. So there is a little homework for you. Just go through the book. If you have PDF or hard copy, just read that, go through, understand, try to understand. If you have any query related to relation and type of relation, please give comment in our video. After some time, after half an hour or 1 hour, this will be in the channel. I also created a playlist in our channel KVS Jabalpur 12th for mathematics videos. You will see all uploaded mathematics video in that. You can see this video also there and comment there, go through them. You have take 2-3-4 hours, go through the topics, comment if any query, then try the questions of exercise 1.1. In next video, day after tomorrow, we will solve the exercise 1.1, and if you have any query, you will mention in comment. I will consider those questions, I will take care of those questions, and we will deeply in a well-mannered way. So I think we are done with this, and I think you must be clear with today's topic. I hope you understood, you liked the video, and be in touch with the series of chapters. And I'm trying to go with the slow pace so that everyone can understand. It should be easier for all. And please share these channels of KVS Jabalpur with your friends, because in this time we can utilize this time by studying these concepts, by learning. If you have any query, you can mention in comments after the video uploads. And Thank you very much for watching. Meet you on day after tomorrow and on 24th April 2020. Thank you very much for watching this video lecture. Thank you very much.